In this video, we will show the trend line and polynomial of the GAMMADIST function for the probability density function and the cumulative distribution function. We begin with the value of alpha, which is data validation, list of items, 1, 2, 3, 4, 5, and 6. So these are the values of alpha. Save. So we have values of alpha from 1 to 6. Likewise, beta. So data validation, list of items, also from 1 to 6. So our beta can start from 1 up to 6. Now we generate the dataset of the GAMMADIST in the probability density functions. Array formula, GAMMADIST of the x values, where this is our alpha and beta, and 0 because this is the probability density function. Likewise, for the cumulative distribution function, so array formula, GAMMADIST of the x values, where this is our alpha and this is our beta, and 1 because this is the cumulative distribution function. And we continue with the equivalent of the probability density function, which is array formula, exponent of the negative x divided by beta. That's beta. And this is multiplied by x to the power, x raised to the power, the quantity a minus 1. So alpha minus 1. So alpha minus 1 divided by, there are two parts. The first part is gamma alpha. That's the first part. The second part times beta to the power alpha. So beta raised to the power alpha. And enter. Their values are exactly the same. Next, we continue with the GAMMADIST cumulative distribution function, which is a Taylor-Maclaurin series sum, where we have x over beta raised to the power alpha divided by gamma of alpha times the summation of a times x to the power n, where a, which is the coefficient, is negative 1 over beta to the power n raised to the power n times factorial n times alpha, the quantity alpha plus n, and our value for n from 0 to infinity. In this case, 16 is good enough. So we continue with the coefficient. So array formula, negative 1 raised to the power n divided by, the denominator has three parts. The first part, that is beta raised to the power n. That's the first part. Times the second part, factorial n. That's the second part. And finally, the third part, which is the quantity alpha plus n. So the quantity alpha plus n. And enter. Now we continue with the Taylor-Maclaurin series sum expansion. So array formula. The first portion is x over beta raised to the power alpha. So the quantity x over beta raised to the power alpha. That's the first part. And this is divided by gamma of alpha. So gamma of alpha. Now that we have that expression, we multiply to this quantity to the series sum. So this is now the series sum. Series sum of the x values raised to the power n. Our n starts from 0, incremented by 1. That's x to the n, times the coefficients. The coefficient a will be this range. And enter. And we'll chart this. So insert chart. And we'll use scatter chart for this. Scatter chart. Row 1 as header. And customize. Series. Trend line. Polynomial. To the 6th degree. For the label, use the equation. For the legend, position at the bottom. And we'll simplify the vertical axis. The number format will be none. That's simplified. And here's our trend line and polynomial to the 6th degree. We will calculate this regression, polynomial regression coefficients using Linest. So we'll set this aside. And set this aside and complete the Linest matrix. Starting with the power. This will be transpose 0 to 6. And the elements of the matrix. So array formula of the x values raised to the power 0 to 6. Then enter. Now we'll calculate Linest polynomial regression. So this is Linest data y and data x. Also Linest data y and data x. And this is also Linest data y and data x. And finally, this is also Linest data y and data x. And we'll compare the polynomial regression coefficients with our polynomial in the chart. So here we have 1, 0, 0. So that's the coefficient of x to the 0. That's 1, 0, 0. This is 0 because it is 10 times 10 to the minus 33, 10 times 10 to the minus 34. Coefficient of x, 0.987. This is 0.987. This is negative, and this is positive. And x squared, that's 0.466. And this is also 0.466 negative. Coefficient of x cubed, 0.131. This is negative 0.131. This is positive 0.131. There's a slight error because this is only The third one is only an approximation. The Taylor-Maclaurin series sum is only an approximation. There's a slight error now. X to the fourth. We have 0.0226, 0.0226. This is 0.0226. And this is 0.0226 negative and negative 0.0215 again, because it's an approximation up to 16th. There is a slight error. X to the fifth. That's 2.17 times 10 to the minus 3 negative, and it is 2.17 times 10 to the minus 3, and this is already 1.98. There's a slight error because this is only an approximation of n up to 16. And x to the 6, 8.86 times 10 to the minus 5, that's it. And this is minus 8.86 times 10 to the minus 5, minus 7.57 times 10 to the minus 5. Suppose we increase this to 2 at alpha equals 2. Our beta can go as 2, can go to 3, and can go as far as 4. Suppose this is alpha equals 3. We can start from beta at 1. This is 1. There's now a slight error because the green, which is this, is only an approximation. So this is our expansion is only approximation. That's a slight error. That's because it's an approximation. We can reduce this error by increasing our value of n to higher, like 100. At beta equals 2, and beta equals 3. And so the values are the same as we go higher in beta. Beta equals 4. So this completes the use of the Taylor-Maclaurin series sum expansion and Linus polynomial regression to generate the trend line and trend line polynomials of the GAMMADIST function.